I'm teaching another class that is the operating system. One of the students upload the class project to the freelancer.com. You know the freelancer.com. That is the website you can hire someone for your IT project, or even not only IT project, but it can be like the presentation or the part-time employee you can hire. So, but I found that this one, and also there are groups who would like to detect academic cheating or the academic plagiarism by uploading the class project for bidding, and by paying the we'd like to find the student who would like to buy the classroom project or program by paying the money. So this is definitely the plagiarism and also the cheating. And if in case the student is caught, so automatically expelled. Okay? There is no exception, and I know not easy to identify right now. The freelancer.com, they like to hide the user information a lot, but I already reported to the department and school of engineering. And more serious thing is this student, he or she already did a couple of times already. It's a 5-star review, and so don't try such a stupid thing. Okay, please. This is the third time. The first time, it was not difficult. At the time, freelancer.com is easy to identify user location and the user information. So then at the time I gave the effort. Then second time, right after I put, the student actually confessed to me. She said she didn't realize whether this is a cheating or not, just for fun upload and would like to refer that. So it was okay because she confessed right away. But yeah, please, I don't think this may be possible. I'm not sure. So, but I keep watching the class project. Even these students are very lazy. Upload the project, the PDF file as it is. So you don't need such a student. Okay? And also, GA suggests me, and it's reasonable to little bit change the schedule of exercise lab next week. After the midterm exam, why don't we have the lab 7 first? Because we already covered the school today, so we can do this one. Because it needs the developer VM, so we can do the lab in this room. Then we can do the 5 and 6 together. So because the 6 require the cluster system. So once you successful, we can keep using that cluster for the next lab. So that will be 27 together. That will be, I think, the more convenient and reasonable. So next week, why don't you bring your laptop with the same virtual machine that you have used so far? Then we can test with your virtual machine for the school. So at the time we will use the MySQL for the data source and your HDFS for the destination to export and import. Okay? Is it okay? Yeah. So we don't have to move to the room. We can still use after the midterm exam. Okay? Any question regarding to the midterm and next exercise lab? And just remember that you have the 6 multiple choices. Okay? And each of them is worthwhile 5 points. It's a 30-point total. And the others are the short description, the very short, okay? And some open-ended question. It's almost a pseudocode and the input and output of the reduced program. Okay? The next ecosystem that we are going to discuss is the NoSQL database. Have you ever heard about the NoSQL? No means it's not negative. Usually it means it's not only SQL, which means we have seen the still relational database model is the most used database management system. And the NoSQL database, there are a lot of problems. So if you already took my course for the advanced database design, do I like the Oracle database? No, absolutely not. It's really hate that was one of the reasons why I quit my job as a database administrator. So Oracle has been the top, the market share, the software in, even Oracle is not only the database, it's in the software industry, it's a top company, right? So, but very expensive and not easy to be customized, and even academic itself, like the database design, is not very flexible. And it requires a lot of constraint and some the condition. So which means that nowadays we have the variety of the data. One of the characteristics of the big data is there's no structure, okay, unstructured data. But think about the relational database, it's a structure. It's too much structure because of the relational database cannot support even multi-valued one. No array, no vector, no linked list, like such a typical data structure are not implemented in the relational database. At that time, when relational database model was proposed, idea is, can we manage the very large data? So that was the idea. When it's in 1960. In the 1960s, we didn't have the enough storage, we didn't have the enough memory, we didn't have the enough bandwidth. At that time, too many. At that time, the big data, very large data means like the less than megabyte. Okay, such a megabyte size. To manage such a megabyte level, so we need the relational database model. We still use. Why? Because the relational model is good enough? No, absolutely not. So there's a limitation. Think about the program language. What program language are you using? So object-oriented program. Even our curriculum already replaced the old program language C or C++. Even though I'm still using C or C++ for my classroom project, and also software engineering. So UML modeling is use case modeling is more popular, and nobody use the flow chart to design and model the software, right? So, however, our database model is a still relational database model. So, which means it's limited. Not only just because the size of the data, but also the modeling itself is not very flexible. Because of that, we need the help of NoSQL database. So the Hadoop, using the Hadoop, we can address a lot of problems of the relational model. By the way, why the Oracle or the relational model is still top the market share, the software in database? Why?
Most of the people are using.
Why most of the people are using?
Follows most of the rules.
Except real-time query.
Real-time. There are benefits, yes, it is true. Oracle is very reliable for the online transaction system. Okay, not even among the relational database management system market, the Oracle is one of the top. So it's very reliable, and but it's very expensive, costly. So even though we have the small size of the data, one time when I visited the small, medium-sized company, they use the Oracle database management system. Actually, it's a part of the set, but they paid a lot of money. But their total size of the database is even several the 100 megabytes. Okay, they can use a MySQL, they can use a SQL Server, even they can use the MS Access, maybe right? But still, Oracle is a top market share, or the other, the Informix DB2 and SQL Server, they are still the best one. Why? It's kind of cartel. Okay, it's very hard to get into the database market, even though you have the relational database management system. Developing it, it's not very difficult. you guys can do that. It can be some of the university are using the implementing relational database management system as a classroom project. I did one time, so but after that the policies changed. I need to because we have the small size of the undergraduate student. It's 350 is closely listed with the 551, so I cannot do advanced part. But when I taught the advanced part only for the graduate student, in classroom we implement a very simple relational database management system. The relational model is very easy to understand, very easy to implement. That is one of the benefits. However, the market, the IBM, DB2, it's a big market actually, really big market. That's the reason we are using the relational model. So they don't want to lose their pie. If they change into the object-oriented database model, the market share will be entirely changing. One of them, nobody knows whether they lose all the pie or not, right? You don't want to do that, right? So nobody will do it. So because of that, really, the academia, like the researcher, like us, me and you, when I was the PhD student, the first fresh PhD student, I came by in my old university there were 5 the professor who majored in the database. So it's a big university. But at the time I visited all 5 professors and asked I tried to do research in the database. I had experience on the relational database, so whether I'm very interested in to develop the algorithm, something like that. But they said, no, there's no more opportunity in relational database in academia. Nobody actually did. It's true. Last 10 years, is there any technical paper that propose a new? I think the couple of things like the materialized view and then otherwise there's no concept, there's nothing changing in academia also. Because even the group of the people in the database, they exclude the academia. When they propose the standard, the SQL standard 2, 1, 2, 3, the professor and the researcher from the industry, and they work together. But right now, only the industry, they are doing everything. So, however, we see the possibility to change such a trend. That is a NoSQL database. Because our current data source are the social media. Why don't you? Is there any PhD student here? Nowadays, many of the PhD students are interested in doing research in social media data because it's a very hot topic. So, and also, some of the students are interested to get a job in such the social media site like so a lot of the opportunity in because we are in the East Coast, it's not easy to get close work with such a company. But when in West Coast, there's a lot of company. So it's, even though startup company, within 2 years they can be big company in social media. So nobody knows changing. Their data source, data are not organized by the relational. Okay, they are different. Mostly they use the network, the graph, and the graph modeling, and some more flexible. And also they use a lot of the multimedia data, and a lot of video data, and audio data, and even text data. And also huge amount that cannot be affordable by the relational database. So, how can we address even the head group think about to address that one? That is the NoSQL database. It's not only SQL. Okay, SQL represents the traditional database. Okay, not just a SQL, it's a traditional database. Not only relational database, it's more flexible and even schema list. What is a schema list? So how can you implement a relational database system? You need to design first. Always a design first. Without designing, you cannot create the database. So designing means that you need to make the schema first. And all data should fit to that schema. Otherwise, you cannot insert the data. There's a way to work around like the null data or something the user constraint, but still it's very limited. So our data, the current data from the internet, social media, such a data. So we need the more flexible schema list. Okay, you don't have to define the schema description of the log data. Okay, as long as we can get the value and key, that's enough. Okay, so that is the idea of the NoSQL database. So we will see very briefly about the NoSQL database. So by comparing with, comparing with what? The relational database. Okay? And those who are interested more about the NoSQL database, I'm going to offer the NoSQL database course in spring. So in spring, I'm going to offer both NoSQL database and data mining. So as I introduced at the beginning of the class, those who are interested in the concentration on the big data system, I can offer the advanced database design is offered every semester, and this semester big data, and next semester the data mining and the NoSQL databases. So you guys can complete the full requirement by May 2016. Okay. But today we will see very briefly the taste of the NoSQL database. Okay. That's the history I already mentioned, and those who complete the 551 advanced database design already know about such a problem of the big data. Not big data, relational database. Okay. However, still, relational database is the major primary database source. That's true. Okay. Which means do not throw away your knowledge and the experience on the relational database model. I think at least the next 5 years to 10 years. But after 10 years, nobody knows, right? Which means I can still use the relational model in my course. But I'm thinking a little bit change it, but the main problem is the undergraduate. So if I'd like to more focus on the algorithm part in the even relational database system like query processing. They can be not directly used for your application later, but the idea can be used for the bunch of other things. So it's much more interesting. Also, the transaction control, buffer management, the indexing, those are very good exercise and the experience on the computer science. Issue is always how to scale up. The database, relational database can be scaled up. What do you think? Yes or no? In other words, relational database can be the distributed database. Theoretically, yes, you can do that. The MySQL, several years ago, before I offered the big data and the NoSQL database, I offered the distributed database system. At that time, one of the project was the implementing distributed database using PlayStation 3. You can see the poster that I made several years ago. So we installed the Fedora OS, the Unix OS, then make the distributed operating systems, kind of simple cluster. Then we insert the MySQL, distributed version, MySQL. Then it's parallelly running. At that time, for example, if we implement the distributed data, so we have the cluster and storage. This is a logical. So it can be one data source, but using the same, but logically it's connected like this. Then we have an employee table. How can we get the benefit of employee? So we need to distribute this way, which means this is for employee of the New York. This is for the San Francisco. This is for the Dallas. We can distribute such a way. So if you access only this one, like the select from employee where location is the New York, or this one you can get the benefit. However, if you group by and count whatever, you need to access separately. And even it will be worse if you join with a department. The department is also the distributed. And join with this one, join with this one, more complicated. We cannot get the full benefit of this. Also, somebody may be considering, from employee, I can keep all employee information, but this one has the name on the PK. And PK with, this is the address. PK with, this is the location. Like that. You can distribute by the column, actually. This is working depending on the application, but what if I go to select SRS? Anyway, you need to access, then transfer the data, it will be worse when you join the table. So we cannot actually get the full benefit of the distributed system, cluster system, when we are using the RDBMS because of the nature of relational model. Okay? Because our goal of the relational model is what? Removing redundant information. How can you do that? Segment to segment, normalization. Then we can for the ideal case, it can be only one data for each. Then how can you access all the data? Using join operation. But join is very expensive. It's more expensive when you have the distributed. So that is a problem. So it's almost. So most of the system, when they have the very large data, they try to integrate to one. Then the operating system, or the hardware, the system, you can upgrade, but it will be limited, right? So that is the problem of the relational model. Okay? And also, even though we are using the distributed system, very hard for the design. During the design horizontal partition and vertical partition, you need to consider a lot of things and network overhead. When you join, even when it depends on the application, it's very complicated, you cannot get the full credit. Okay? When also data warehousing, limitedly you can use the distributed system, like such as the NPP machine. NPP is the massive processor. Okay, it has one node. One node has their own the CPU, memory, and the local hard disk drive, and connect to the cell. And each node, and parallel it can process. Like the 36 node, 100 node, 1000 node, parallel. To do that, your data set should be the segmented. Mostly denormalized. Denormalized means to put all the data into one. The table, for example, then the horizontally, the segment, like this is custom 1 through 10, custom 11 through 20, and 31 through 40, something like that. Then parallelly process and from the master node and collect all the result, but very, very limited. Okay. So to address that problem, the Hadoop community proposed the NoSQL database that is basically start from the HBase. Okay, so we will see such a thing. Then, always better? No, we lose this kind of a trade-off. So we lose some of the functionality in the relational database. For example, one of the benefits of using IDBMS is very reliable for the online transaction system. Okay, which means if you log on first at the bid in the eBay bid first, then that will be the applied. So we never ever lose such a data, even though system down, we can keep the how using the ACID transaction property. So we will see what is the ACID. Do you remember? Atomicity. Good. Then C. consistency, that's the problem. Isolation. When you update the data, it's isolated. Okay? So no other transaction cannot access the data until when? Coming. Okay? So for example, current value is 1, I'm updating to 2. So until I commit, the other you can see only the old data, 1, isolated. But when I look up my data, change data, I can see even before it's isolated. When you commit, it will be released. Then D is durability. Okay? If that is applied, then no matter what happens, system is down and the earthquake, whatever, it will be the 2. Okay? So that is ACI. Because of that, relational database is very reliable for such online transaction system. However, data warehousing, think about the data warehousing. So I'd like to average 1 million of the customer, okay, to see the trend of whether the overall is increased or decreased, the balance. Even though you may lose 10% of even one customer information may not affect a lot. Okay. So because based on that idea, why don't we relax such a property that is a cap theorem. So cap theorem, we may lose a little bit consistency or availability or the partition. So even though we lose some of them, but our goal is what? Process big data. Okay, huge amount of the data. We may lose consistency, but our goal is to process. Even though among the 1 billion of data, does it affect even though we lose one transaction? May not affect it. Okay? So that is the idea of the NoSQL database. So this is the starting of the kind of father of the NoSQL database, Dynamo and the BigTable. BigTable from the Google. This is your third reading assignment. Okay, the first one is the Google file system. That is the father of the HDFS. And second is the MapReduce programming. And third one is the BigTable. That is a kind of father of the HBase NoSQL database in the header. So BigTable and Dynamo in the Amazon. Okay, these are the you can find the paper from our reading assignment of this one. You can find the Dynamo, the database. So we will see the example of the Dynamo in the NoSQL database, not this one. So we will see only the HBase in this class. And the cap theorem is the fundamental of the NoSQL database. So in this class we will see what is a cap theorem. Okay. So cap theorem, there are three things that required for the distributed database. Consistency you know. So is the database. What is the database state? In relational database model. Current data and schema. So schema and data. So this is a current state. So when you do any transaction, so database state can be changed. So consistency means so one state to another state. It's a consistency. So also anyone can see the same data when you update, when you change the data, because it's a consistent. Okay. Then availability should be the big data system require. It's not actually cap theorem is not from the big data. It's from the distributed system. Okay. But the big data adapt that cap theorem. Availability means it should even though the one of the server or the node is down, it's still available. Okay, should be available. This system, if one of them is failed, this data is not available. Right? So this is that is the reason it cannot be fully function the distributed system. Partition tolerance means that so we can partition, distribute the data. Okay, distribute the data. So idea is we cannot keep the all three property in distributed system. Doesn't make sense. Why? For example, the data is partition. So data is partition. Can we get the availability and consistency? So for example, consistency means once this one is changed 1 to 2, it can be from anywhere should be 2. Okay? To implement that one, you need to propagate, like using the memory channel or network, it should be synchronized at real time. Then availability means once the one of them fails, this data is not available. Okay? To address that one, to keep the availability, we need to have the multiple copy. So if we have the multiple copy, it will not be consistent. For example, think about the Facebook. When you post a message, it cannot be viewed. Not all the user. Okay? Sometimes even you cannot see the like. I click the like, but it's not increased. Why? Because it has the in big data system, mostly they focus on more in the availability instead of consistency. However, relational model focus on what? Consistency. Okay? But they do not have the, because of that partition, it's not good for the relational model when we need a high consistency. Okay? That is the cap theorem. Cap theorem means among three the property of the distributed system, at most we can keep only 2 of them. So most of the big data system, NoSQL database focus on partition tolerance and availability by losing some consistency. It's a delay sometimes. It's called the base. We will see later. So because of that, so when you are using social media data, it's not the synchronized real time. Okay? Okay, so consistency, once the write is done, and it will be shown. So it's very important in the online transaction and, for example, the relational model. Okay? There are different types of consistency. One is very strong, which is in the IDBMS, right? ACID. Okay? Optimistic consistency, isolation, and durability. Base is relaxed, the consistency, which means eventually it's synchronized. But anyway, it will be synchronized, but later, delayed. That is the base. Many of the NoSQL database or the social media site, they use the base, the consistency. So this is the ACID that we have run in the RDB. Okay. Atomic, which means it's yes or no. Okay, it's atomic. It cannot be divided. So once it is done, it's